Yeah, I always let them upload when I'm done. I'm just going to wait a few minutes for people to join. Yeah, I can do some stuff with sorting algorithms. Do you have any particular that you want to go over? If not, I'll just go over some of the basic ones, like insertion sorting algorithms. Do you have any particular that you want to go over? Yeah, I had the stream playing in the background. I just turned the sound off. Thank you, though. So there shouldn't be an echo at this point. So I'll be getting started in about a minute. So I'm just going to start off by looking at this one. This is the first question from the 2015 AP exam. Specifically looking at free response questions. Free response questions are generally a lot easier to go over in a video format like this, so I'm just going to stick with this. So the first question I like because it's actually pretty generalized for an AP question. A lot of times the AP questions require a lot more reading comprehension than this. And these are sort of just testing your fundamental knowledge of how one-dimensional and two-dimensional arrays work, which is honestly a lot easier than some of the other questions that they end up putting on. So the first question says, so you're going to write 3 static methods, all which are in a single enclosing class named diverse array. So part A says, write a static method array sum that calculates and returns the sum of the entries in the specified one-dimensional array. The following example shows an array R1 and the value returned by a call to array sum. So if this is the array being passed as a parameter into the array sum method, then it's going to add 1, 3, 2, 7, and 3 together to get 16. So let's just do this one. This one's pretty easy. So it just returns the int, or it just returns the sum of all the elements in the array as an int. So nothing too difficult about this one. And I'm just going to save this file as a .java file, just so we get the nice color templating. So if we want to go through the array, all we really have to do is just use a for loop. Anytime that they ask you to get the sum of something, it's almost always just setting up a variable as an int called sum, setting it to 0, that we're going to be returning later. And then we're going to be returning sum at the end. So all we really have to do is just use a for loop, say for int index gets 0, while index is less than r.length, index plus plus, and then just say sum plus equals r index, and that's really it. So the idea is just like we set up the sum, set it to 0. We have a for loop that iterates through the array ARR, and then we just add all the elements that we come across from ARR to this variable sum, and then we just return sum. So I'm not going to go over that one anymore, just because I think that one's very, very easy for an AP problem. So this one says write a static method row sums that calculates the sum of each of the rows in a given two-dimensional array and returns these sums in a one-dimensional array. The method has one parameter, a two-dimensional array R2D of int values. The array is in row major order. R2D RC is the entry at row R in column C. The method returns a one-dimensional array with one entry for each row of R2D, such that each entry is the sum of the corresponding row in R2D. For example, if mat1 is the array represented in the following table, the one down here, it's going to return 16, 32, 28, and 20. And the reason for that is just because it's basically just going to set up a new array that's going to contain the sums of all the rows. It's going to add up all of the values from each of these rows and then just put it in its respective index. So essentially the index of the array that we're returning, each index is the sum of the row at that index of the initial two-dimensional array that's being passed as a parameter. So let's get to it. So it does say that you must use array sum appropriately to receive full credit. That means that you actually have to use the method that we just wrote. And it says you can assume that it works as specified, meaning that you can just call the method and assume it does what it's supposed to do. So for this one, we're going to be getting a one-dimensional array that is the size of the number of rows of R2D. And if you think about it, that makes sense because we're returning an array that contains all of the sums for each of the rows from R2D. So we need a one-dimensional array that matches that size. So the first thing I'm going to do is make a int array called row sums. And I'm going to say gets new int, and then the size is going to be r2d.length. So remember that if you want the number of rows in a two-dimensional array, it's going to be r2d.length, but if you want the number of columns, you'd put a brackets and then 0 here to indicate essentially you're getting the length of the 0th row. And that'll give you the number of columns, but the idea here is that we want to get the number of rows. So then what we can do is we can say for int row gets 0, while row is less than r2d.length, row plus plus. We can say row sums row is equal to, what's the first method called? Array sum is equal to array sum, and then r2d row. And at the end, we can just say return row sums. So for this one, the idea is that we're passing an entire row as the parameter into array sum. So r2d row, just saying that, even though it's a two-dimensional array, if we just give it one coordinate that we're looking at, it's going to return the entire row as an array rather than just one singular element of the two-dimensional array. So we pass that into array sum, and then that's going to give us the total sum of each of the elements in there. And then we just set the index row of row sums to whatever that sum is. And then at the end we can just return row sums. So let's look at part C. So a two-dimensional array is diverse if no two of its rows have entries that sum to the same value. In the following examples, the array mat1 is diverse because each row sum is different, but the array mat2 is not diverse because the first and last rows have the same sum. So write a static method is diverse that determines whether or not a given two-dimensional array is diverse. The method has one parameter, 2D array R2D of int values. The method should return true if all the row sums in the given array are unique, otherwise it should return false. In the array shown above, the call is diverse mat1 returns true, and the call is diverse mat2 returns false. So the idea is that for the first matrix that we're looking at, the first two-dimensional array, none of the row sums match, which means that that is not a diverse array. For mat2, we see that row sums for 0 and 3 are the same, so that's going to return false. So it says, assume that array sum and row sums work as specified regardless of what you wrote in part A and part B. You must use row sums appropriately to receive full credit. So we have to use what we did last time to receive full credit for this question. So to start this one off, I'm just going to make a array called row sums array that's just going to be row sums R2D. So we're essentially using what we did in part B, where we get the full one-dimensional array of all the sums of each of the rows. And since we have that now, all we really have to do is see if it turns into a different problem, which is how do you figure out if there are two matching parts of a one-dimensional array. So to do that, I'm just going to use two for loops, set that to A, and for this one I'm going to say while A is less than R2D minus 1, and A++ here, and for int B gets 1. I can probably do it another, yeah, that's fine. So we'll say B is 1, and here, I'll just do it like this. So also I forgot dot length here. So we're going to say while B is less than R2D dot length, we're going to keep iterating through B++. And I'm just going to put the caveat in here, and we'll say if A does not equal B. The idea is that we don't want to compare two rows that are the same. There are slightly more elegant ways we could do this. Like, for example, this could be solved very easily using a hash map or a hash set, but we're not gonna bother with that just because that's not part of the AP subset. So I'm just going to use this nested for loop solution. So we'll say if A does not equal B, meaning that we're not looking at the same row, we can say if row sums array A is equal to row sums array B, which is where we're checking for equality of the rows, we just return false. And then all we really have to do after that is, let me just put an extra curly brace in here. We can actually just return true at the end. Now, I am going to show you a one thing that people end up getting wrong a lot on this is that instead of saying return true at the end, they say else return true. But that's not going to work, because if we just return true, it means we just made one comparison as we passed through that entire array. And as long as the first two elements that we check are not the same, then we're just going to return true without checking everything else. This is a super common mistake. So what you want to make sure you do is you only return false inside the for loop, and then we end the method, because methods end when we return something. And then you can just say return true at the end, which is sort of like what we end up defaulting to. So we sort of like assume that it's going to be true, and then we just return false if we find two rows are equal. So that's everything for this. So that's going to be question 1. So let's take a look at number 2. And this one, if I remember, is pretty annoying, but we'll go through it because I want to do one that has to do with setting up a class as well, not just algorithm stuff. So it says, consider a guessing game in which a player tries to guess a hidden word. The hidden word contains only capital letters and has a length known to the player. A guess contains only capital letters and has the same length as the hidden word. After a guess is made, the player is given a hint that is based on a comparison between the hidden word and the guess. Each position in the hint contains a character that corresponds to the letter in the same position in the guess. The following rules determine the characters that appear in the hint. So the idea is if the letter in the guess is also in the same position in the hidden word, the corresponding character in the hint is the matching letter. If the letter in the guess is also in the hidden word but in a different position, then you get a plus. And if the letter in the guess is not in the hidden word, then you put the star there. So the hidden word class will be used to represent the hidden word in the game. The hidden word is passed to the constructor. The class contains a method getHint that takes a guess and produces a hint. For example, suppose the variable puzzle is declared as follows, and we see a sample invocation of the constructor here. The following table shows several guesses and the hints that would be produced. So if you tried getHint for AAA, or like quintuple A, it's going to return plus A plus plus plus. Hello is going to give you H, and then ELLO, and then heart is going to give you H star plus plus star. I'm not going to go through the rest of that. So it says write the complete hidden word class, including any necessary instance variables, its constructor, and the method getHint described above. You may assume that the length of the guess is the same as the length of the hidden word. So when you're designing the classes, they sort of give you a open-ended scenario as far as coding goes, and they want you to use object-oriented principles to create something that's going to make sense. So we're going to start off, so it's the hidden word class. So hidden word isn't going to be a subclass or implementing an interface or abstract or anything like that, so we can just say public class hidden word and just leave it at that. So let's take a look at what we need. We need any necessary instance variables. We need a constructor because it actually showed us an example of a constructor being invoked, and then we definitely need a getHint method. Now we might want to add more as we go along, but for now we can just assume that this is probably going to be fine. So for this one, it says, so essentially what we're doing is when we make a new puzzle, we're passing a new, we're passing something that people have to guess here. So we know that there's going to be some instance variable probably that's going to be like word to guess. So I'm going to go ahead and say private string word to guess goes here. We might add some more instance variables later, but for now I'm just gonna write the constructor. So we'll say public hidden word, and that's going to be passed a value for word to guess. So we can just say this dot word to guess gets word to guess. So that should set up the constructor for now. You know, we might want to just try something else later, but for now I'm just going to keep that. So let's take a look and see what the specifications for the getHint method are. So it says, where's getInt? Okay, the class contains a method getHint that takes a guess and produces a hint. So it looks like it's passed a string, and then it's going to return something else. So let's go ahead and write the getHint method so that it takes a string in, and then it's going to return a string. String is, we'll call that guess. And then we're going to go ahead and start doing this whole algorithm thing. So if you remember, what it does is it looks through the word. So it takes your guess and then it looks through the word, and then it's just going to return like plus, star, or the actual letter, depending on whether or not you got it right or not. So there are three things. So it's we have to consider when the letter is in the correct place. We have to consider when the letter is in the incorrect place, but's in the word somewhere. And then we also have to consider when the letter is not in word to guess at all. So to do this one, I'm just going to go ahead and iterate through. I'm just going to iterate through guess. So I'm going to say int index gets 0 while index is less than guess.length. And then index plus plus. So one thing I actually want to check is whether or not it says anything about whether or not you know that the guess is the same length as the word itself. So I just want to make sure I don't do anything I'm not supposed to do. So I don't see anything. I don't see anything specifically about the difference between get hint and the word itself, which makes it a little bit stranger. But we'll just go through it like that. That's fine. We can just assume that if okay, so let's just go through it. So first we'll check to see if the letter is in the correct place. So we'll say if guess.charatIndex it is equal to word to guess.charatIndex. So that would indicate that. So one thing I'm actually going to put, put up first is I'm going to set up the string that we're going to be returning. I'll say string returned hint, and we'll set that up just initially as a blank string with 0 characters. So we say if guess.charatIndex is equal to word.guess.charatIndex, so that's testing for whether or not it's in the right place. Then we can say returned hint plus equals guess.charatIndex. So basically like whatever character we're currently on. So that'll set it up for if the letter is in the correct place. So let's look and see the letter is in the incorrect place, but in the word somewhere. So by the way, I'm going to point out for anybody that really cares about this, I'm not writing these to be particularly algorithmically efficient. I'm trying to write these so that they utilize the AP subset, and it's more similar to how the rubrics of the AP would have answered this question. So this is not a particularly algorithmically efficient answer, as you're going to find in 1 second. I might actually change how it works later, but we'll see how it goes. So if the letter is in the incorrect place, but in the word somewhere. So for this one, I'm actually going to, this is going to look very silly because I'm essentially just putting in a second for loop, but it does solve the problem at hand. So we're going to be iterating through word to guess. So we'll call this word to guess index, set that to 0. And while word to guess index is less than word to guess dot length, and then word to guess index plus plus. I'm going to go ahead and just make this a single letter because I'm not going to deal with, All right. That's much nicer looking, at least. Alright, so what we're going to do is we're going to iterate through word to guess, and we're going to see if any of the letters match where we currently are. So we can say if word to guess dot char at a is equal to guess dot char at a, or guess dot char at index, because we're actually just going to be like looking at the current guesses index. Then we can say returned hint plus equals, and that's plus. And as soon as we do that, I would actually just want to break out of this for loop. So I'm just going to say break, because we don't want doing it again. I think it's the plus for that, right? Yeah. So, and then let's check the letter is not in the word at all. So I can set up a for loop that's very similar to the previous one, and we can say for int b gets 0 while b is less than word to guess dot length, and then b plus plus, and then we can say something like we'll assume initially that the word is not in it's not in there. So we'll say Boolean letter in word gets false. And then we can say something like if guess.char at b is equal to word to guess.char at index, then letter in word is true. And if not letter in word, then we just say returned hint gets or plus equals star. And then finally at the end of the method we just return returned hint. This wasn't one of my favorite solutions. Let me see if I can find a let me see if I can find another one. So I'm just looking to see if there's going to be a better one that we can look at. Okay, so here's one that will work, and it's honestly a lot better than mine. So for this one, so we start off and it says, I'm just gonna back that up. Okay, so we start off with a string called hint, and string hint is blank, and it says for int I gets 0 while I is less than s dot length I plus plus. And it basically just grabs the current letter that we're looking at, which is a much better way of doing it, really, because we don't want to have to keep typing s dot substring I plus 1. This is basically just going to get the character at the index I. So it's not doing anything else besides that. And this uses if else, which makes more sense, honestly. So it says if letter dot equals word dot substring I plus 1, you add that letter to hint. Else if, this one actually uses index of, which makes a lot of sense because index of will return any number between 0 and, well, really any positive number, any natural number, if the letter is in the word. Otherwise, it will it will return -1. So if it returns -1, we know that that letter is not in the word, so it gives you a plus. Else hint plus equals and then asterisk. And then at the end it just returns hint. So that's a much more it's a much more cogent solution in my opinion. But yeah. So I'm going to go ahead and I'm going to just go ahead and stick these on some website. I don't know, you could probably find these online. That's not really like a huge deal. So for now, instead of going through other free responses, does anybody have any particular things that they'd like to go over? All right, so if nobody has anything in particular they want to go over, we can. I'll just end it there. And but if you guys have any other pressing questions, feel free to just say them in the chat, and I can try to go over them later with you or something. But yeah, good luck tomorrow. Oh, okay. Oh, we're getting stuff. Okay, interfaces. So Charat's actually not in the AP subset, but I ended up just, I used it, but really the AP subset sort of, you're looking at, I'm not sure what that means. So if I like Charat just because it returns the character, so you don't have to mess around with dot equals, but but yeah, Charat's actually not in the AP subset. I mean, it's fine if you use it. You can use anything you want as long as it's Java, but yeah, so I can do some stuff with go over how to get a 5 on the exam for a dumbass. That's I mean, really it's just study and practice. There's really not there's no secrets to it. It's just So what do you mean by matrix? Do you want me to just go over the those problems from part 1 again? Which I can do. I just want to make sure that's like what you're asking for. I really doubt it's possible to get a 3 overnight if you haven't actually put any time into studying or anything like that, but you can try. I think you guys are asking the wrong questions here, although I get it, trust me. It's just not really possible to self-study that quickly for this exam. Yeah, I mean, I can go over the problems from the matrix. So it's like I'll just give you an I'll just give you a problem that I think would be a good question. So imagine that you're given a method that yeah, I can do some inheritance after this. So we have public static int max matrix, and basically max matrix returns the maximum number or the maximum integer in R2D. So that's a pretty simple problem, and it involves iterating through a 2-dimensional array and actually getting all the max and everything. So, and it also shows you how to handle a problem that says find the max, because that's really just not something that's just something that you'll end up seeing a lot on the AP exam. So this camera a little bit. There we go. So anytime you see something that says max, or you're looking to find a max or anything like that, you usually just start off with something like this. I usually say current max, int current max, and there are 2 ways you can do it. One way is just to say integer dot min value. Another way to do it is to say something like int current max gets R2D, 0, 0. And the reason those work is just because when you're trying to set the, or you're trying to find, or you're trying to set a value for whatever the current maximum in that array is, if you say integer.min value, you're guaranteed not to find something less than that. So it actually will, it would work. A lot of people want to do this, which is they would say int current max gets 0. And I'm going to put, not to be too ridiculous, but I'll put like 99 x's there just to make sure you don't do that. I'll even say in the middle, don't do this. Because if you say it's 0, if you have a matrix that's all negative numbers, your current max that you end up returning at the end is just going to be 0. It's a very common mistake, so make sure you don't do that. The two ways you can do this are to say, if you're looking for the max, you say integer.min value, which is the smallest possible integer value in Java. It's like -2 to the 31 minus 1 or something like that, or -2 to the 32. It's one of the two. And then int current max is r2d00, because it just grabs the first value in the array, and then you can just keep comparing as you go along. So that's just something to keep in mind. It's like, this is just like one of the most common mistakes you see on the exam. So I just want to point that out. Also, there are actually multiple choice questions that will ask you things like, you know, which of these will work? And like, it'll give you this, 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 and this. And you have to figure out which ones work and which don't. So let's go through the array. So we can say for int row gets 0. So when I'm iterating through a two-dimensional array, I like to write row and column. You don't have to do that. They're just identifiers. I just like to do it because I think it makes it a lot clearer, to myself at least, what I'm doing. So we can say row plus plus. And then we can say for int col gets 0, while col is less than r2d, and then in brackets 0 dot length. Yeah, so all the free response questions for AP Computer Science are available online. The multiple choices are harder to find. Unfortunately, they make teachers and schools actually pay for those exams so that you have the multiple choice exams available to you. I don't want to, you know, I'd like to feel relaxed this evening, so I'm just going to not talk about College Board itself as an entity. But anyway, you can get the free response questions online, and you can also see the grading rubrics as well. R2D row dot length works fine too. There's nothing wrong with using that. R2D 0 dot length is just a fair one to consistently use, because if you don't automatically know the size of your array or something like that, it's generally just better to use 0, or it's more conventional. But using R2D row would be perfectly fine. That would work too. All right, so now we just have to make the comparison of the current value to current max. So we say if R2D and then row col, sorry, I need parentheses because of Python. If R2D row col is greater than current max, then we'll say current max gets R2D row col. So we're saying that whatever we're currently looking at, if that number is bigger than whatever our current max is, then we just set the current max to whatever R2D row col is, so whatever we're looking at. So that's where we make that swap. It's not really a swap, or not a swap, but that's where we make the reassignment of current max to what we're looking at. And at the end, we just say return current max, and then the way you would get the minimum is really the same, except you would just change like two things. You would just say current min, integer.max value, and then you would say if R2D row col is less than current max, and that's it. So if anybody has any questions about that, you can just let me know, and I'll try to go over them. Okay, so if not, I'm just going to go over some more complex recursion problems. Yeah, I can find some recursion problems. I have to, let me just find them real quick. And inheritance. Actually, I said inheritance first, so I'll do a little bit of inheritance, and then I'll go over some recursion stuff. So this is, I'll just give you an example of, let me just think for a second. I'll give you an example of inheritance along with abstract classes at the same time. And I'll give you an example that I think is generally pretty good. So this is inheritance and abstract classes, because they tend to show up. I mean, like, there are no real hacks to this exam. It's just like, so it's really, you just want to, one of the things you can do on the FRQs is, as long as you declare the variable that you want and then return that variable at the end, that'll usually just get you at least 2 points on the FRQ. So if you want a, so if you want something like 3 points, that's the only thing I can really think of that's like a trick, but you can't really just like, if you don't really know the stuff, then it's kind of hard, but you can try. Like, I'm having an issue figuring out what methods a parent object and a child data can do. Okay, well, I'll show you some stuff. So the I'm gonna start off by making an abstract parent class called shape. And I like this as an abstract class because a shape can get a lot of things, but then, or a shape can look a lot of different ways. But there might be some consistent functionality of a shape that we want to have children inherit. So I'm going to start off just by saying, private string name. I'll make a constructor called shape, and then we'll pass name in there, and we'll say this dot name gets name, and I'm going to have a abstract method. Public abstract, and then we're going to return a double, and it's going to be called get area. And when you make an abstract method, you're essentially defining the you're defining what it looks like, but you're not defining what actually goes into it. So in this case, we can just generalize get area like that. And that's all we really need for this abstract class. So let's go ahead and make a subclass. So we'll make public class rectangle extends shape. So what this does is, if you want something to be the subclass of something else, you say extends. So we're saying that rectangle is a subclass of shape. That's what extends will do. So what we can say is, now we can set up some new instance variables. So we can say private int length, private int width. So now I'm going to make the constructor for it. This is a really important part. And so I'm going to say public rectangle, and we're going to be passing 3 different parameters into this constructor, even though there are 2 instance variables, because I want to make sure that we get something for name. So we say string name, or actually we don't need to pass anything because it's going to be called a rectangle anyway. So we'll say int length, int width, and we want to call the super constructor. And to do that, we're going to say super, and then we'll say rectangle to give this object the name rectangle. And then we'll say this dot length gets length, and then this dot width gets width. And the reason I did that was because, so you can't instantiate shape even though it has a constructor, and that's confusing for a lot of people, because usually you think of a constructor as a way to actually make the object in memory, but you can't instantiate an abstract class. You can only call its, but you can call its constructor. Oh, what does this do? So okay, there are a few questions here. So this is really like, so the word this basically just refers to the current object in memory. So when you call shape, So for example, like, or you don't call that, but when you call rectangle, the constructor rectangle, it creates a rectangle object in memory. Or I'll say the Java interpreter creates a new rectangle object in memory. Now that object is empty to begin with, or it has all the default values. So you would say this dot length gets length, because you're saying that this object's length is going to be whatever length is here. So also I want to point out, like, this dot length actually refers to the instance variable length, and then this length, like the one at the end that we're using as a value, refers to the parameter. I'm actually going to change this to in length and then in width, so we don't have to use this, because it might actually make it a bit more obvious what I'm doing. So this would also be fine, and I could use the word this, but it's superfluous. But it makes it obvious exactly like what I'm referring to. So you can say something like this dot length gets in length if we call the parameter in length, and that's pretty much that. So one thing we have to do though is when we extend an abstract class, the subclass is obligated to put in a to define what getArea does. So we're just going to go ahead and do that now. So public double getArea, and that's just return length times width. So we're overriding what getArea does because we have to do that if it's an abstract class. But this is pretty much like what a subclass abstract class looks like. That's pretty much that. So let me read through some of the questions. When you call the constructor of shape, do you need to put a name, or can you just put close parentheses? So you never actually call the constructor. Oh, I see what you're saying down here. So for this, when you call it, do you need to put a name, or can you just put close parentheses? You could actually put close parentheses if you want to, because every class automatically creates a default constructor if a default constructor is not defined by the programmer themselves. So if I did super that, it would actually just give you the value of name would be null, because that's the default value of a string. So you could do that if you want to, but I just passed the parameter because that's how we defined it up here. But you don't necessarily have to do that. So I'll go ahead and just comment that out to show you that, like, you could do that. This calls the default constructor. And I had a few people ask me for some recursion stuff, so I'm just going to go ahead and I'll do some recursion. Actually, I do think the 2016 exam was one of the hardest exams recently when I looked at it. But I wouldn't let that scare you, because the exams are curved. So if people internationally are doing poorly on the exam, then you essentially just get a lot of free points for it. And if you study, then you might actually do fine. I'll say this, it wasn't necessarily harder. It was... it seemed a lot more tedious to me. It seemed like there was a lot more reading to do, which means that people that are maybe good at programming but maybe aren't necessarily as good at reading comprehension really weren't going to do as well, which kind of sucks for them, because it really, I don't think AP Computer Science should be testing your reading comprehension. I think it should be testing how well you can program and do object-oriented stuff. But, that's just me. So let me go over some recursion questions. So I just have to find a couple. So just give me 1 second to find some good questions. Yeah, like, misinterpreting the questions is just unfortunately very common. There's not much you can do besides just reading through. I mean, like, something I would do. So for example, like if you have these kind of questions, like consider a guessing game, like just go through and like start underlining stuff, and so you can just go through and start underlining stuff and just like make notes of what you think might be important. That's all I can really say about it, is just like try to strategize like what you're reading, and then just like be good at like or try to figure out like what the important information is as soon as possible. Unfortunately, it's just kind of hard. Like if you're a slow reader, it's just a tough exam, and there's not too much you can do about it, but you can just try your best. It's I've seen people that are very slow readers get 5s on the exam, so I don't think it's not a death knell. It's just difficult. It's just more difficult. So let me pull up some. Let me pull up a recursion thing. So I'll start off with a fairly simple one. Or a I'll say relatively simple recursion problem. So here's a recursive problem, and then the question is, what value is returned as a result of the call to mystery 5? So we can start tracing through that, and I'm gonna set something else up in the meantime. Java. I'll do this. That's weird. Okay, so I'm just gonna do this. So it says, what value is returned by a call to mystery 5? So I set these up like math expressions that we're just trying to solve. So if we look at what mystery 5 is going to return, yeah, so it would return M. Sorry. So it follows like whatever the constructor is, whatever constructor is used. So for example. So if you said parent park, its new child, it's going to follow that child. If it has a method M1 that says super M1, so if it says super M1, then so if it's calling the superclass, it's going to print out whatever the superclass prints out. Yeah. Yeah. So basically that it's polymorphism. So. People are giving good answers in the chat, fortunately, so I don't have to run my math about it. So for mystery 5, we pass 5 into here, and it says if n equals 0, we return 1. But in this case, 5 is not 0, so we go to the else statement. So it returns 3 times mystery n minus 1, which is 4. So essentially what keeps happening is the recursive call will keep decomposing into other things. So 3 times mystery 4 is still going to be 3 times, so we keep that. But then it's going to be 3 times mystery 3. And really what's happening there is mystery 4 turns into 3 times mystery 3. But 3 times is still there, so that doesn't change. So we'll say equal. So we have 3 times 3 times, and then mystery 3 is going to give us 3 times mystery 2. So essentially mystery 3 turns into 3 times mystery 2. So then we have 3 times 3 times 3 times, and then we have to figure out what mystery 2 is. 2 is not equal to 0, so it's going to return 3 times mystery 1. And then it's going to return 3 times 3 times 3 times 3 times mystery 0. So then we get to our base case, which is here. Remember, that's the base case, and then that's the recursive case. So we get 3 times 3 times 3 times 3 times 3 times 1, because mystery 0 turns into 1. And then we get 3 times 3 times 3 times 3 times 3 times 1, which is 243. So sorry for the kind of whack orientation of these, but you know, okay. But yeah, that's gonna be 243. Okay, so the only 4 3s. Are you sure? I could be wrong. So mystery 5 turns into 3 times mystery 4, which turns into 3 times 3 times mystery 3, which turns into 3 times 3 times 3 times mystery 2, which turns into 4 3s mystery times mystery 1, and then 3 to the 5th times mystery 0. Oh, okay, yeah. So I was going to say, I mean, you know, I could be wrong, but I was pretty sure it was 243. So I'm probably going to take a break, but I will likely be on later. So if you have anything you particularly want me to go over, if you just put them in the chat, you can look for me later, probably in like hour and a half or something like that, because I'd like to do some other things. But yeah, so if you have any questions, just like in about probably like an hour hour and a half is when I intend to be on again. But yeah, feel free to join in then. But yeah, if you have any questions, just put them in the yeah, no problem. I don't mind doing this. So it's yeah, just put it in the chat, and yeah, if I don't see, or if you don't see me, good luck tomorrow.